Hello, everyone, and I would like to welcome all for our Media Futures workshop. The title of the workshop is Detecting Fake News by Using Weekly Supervised Learning. And the seminar will be given by Associate Professor Özlem Özgöbek. Professor Özlem Özgöbek works as an associate professor at the Department of Computer Science at NTNU in Norway. Her research focuses on recommender systems, privacy issues in recommender systems, and disinformation detection for online news. She is also co-founder of Norwegian Big Data Symposium, NOBITS, and actively involved in organizing INRA workshop series since 2014. We have known each other and worked together on some organization and research work. So I am extremely glad that she's going to give us the seminar. I just would like to also mention that this seminar is going to be recorded, as you probably have received this pop-up in the joining phase. And that will be shared afterward in Media Futures page of the seminar. And yeah, that's it. So again, I welcome all. And Professor Özlem, please go ahead by introducing yourself and also the speech. The stage is yours.
Yes, thank you, Mehdi. Thanks for inviting me, first of all. And also, it's really good to see many people here. Yeah, as Mehdi introduced me, my name is Özlem Özgöbek, and I work as an associate professor at the Department of Computer Science at the NTNU in Trondheim. And yeah, today I'm going to talk about fake news detection, and we have an ongoing work started with the work of some of our master students, but we are, yeah, it's still an ongoing work based on that. So today I'm going to present that work to you, but I would like to start with some news from my side. So we have actually, so I'm involved in a lot of organizational tasks, as you can see here. So I thought that it may be of interest of this audience. So we have two special issues, and one of them is the UM/UI special issue on news personalization and analytics. And the other one is Frontiers in Women in Recommender Systems special issue. And then we have the INRA that is going to be the 10th year this year. And I forgot to write its full name. I just so used to the abbreviation of it. It's the International Workshop of News Recommendation and Analytics. So more information will be upcoming. And also we have the Media Eval News Images task. We have this task for a couple of years now. And last year we were collaborating with Mehdi and Tien on this task. So I'm really happy to say that we've been collaborating on this. And we are also planning a new version of this this year. So yeah, these are some news from me. If you are interested in any of these, you are welcome to submit or to collaborate with us in any of these. Going back to the main topic, fake news. So fake news, as you know, probably, fake news is not only one thing. There are many terms and many concepts that is surrounding the fake news. So I know that there are some researchers that is against the use of term fake news actually, while others oppose this view by saying that, okay, we have to say fake news, it is what it is. So obviously there were some, because of some political, yeah, I think this has some political reasons, because it's been used very heavily by certain politicians in the past years. But in addition to disinformation or misinformation, there are other things such as hoax and misleading news and false news. So there are many terms that accompany the term fake news. So I'm going to be using the term fake news, even though I actually like the distinguishment between disinformation and misinformation. So for the ones who doesn't know about the difference, disinformation is more, it is about the intention behind these type of false news, while the misinformation doesn't have to have an intention of misleading. So there are also not very clear borders between these different concepts. There is propaganda, there is satire. So when we think about, also there are like clickbaits and all types of different terms around it. And when we think about the computers and how actually we can distinguish these different terms from each other, it becomes a very challenging task. And when it comes to the importance of fake news, I guess I don't need to tell much about this, because especially during the COVID-19 pandemic, we have seen that this has actually some practical outcomes for the whole society in a bigger scale, actually. So of course, obviously before that, we were also aware the consequences of this, but I guess the pandemic helped us to see that how it can be in a bigger scale. So today, most of the fact-checking or the detection of fake news or disinformation or misinformation is happening by manual fact-checking still, because that is the most trusted way still we have. This is a figure from the Reporters Lab, where you can see the URL here. So there are manual fact-checking organizations all around the globe, around 350 active organizations by today. So these organizations, for example, in Norway, that is faktisk.no, and in some countries there are more than one organizations. They consist of professional journalists really researching about the information that is included in the news articles, so they can actually label it. And this labeling is usually not binary, it is not false or not, but it can also include a degree of facts, or maybe there are some claims that is false in the articles and such. But also there are a lot of efforts going on in means of automatic fake news detection. And there are so many ways of looking at this problem. So it is sometimes only detecting it in mainstream media articles. Sometimes it is about detecting it on social media. And of course, social media analysis is then one of the approaches that people look into. Detecting spreaders instead of detecting fake news itself is another approach. There has been some work about the stylistic features of fake news articles that actually it shows that the language of these articles can be very different than the trusted news or the real news. Also, there are some different techniques. So there are supervised approaches, weakly supervised approaches, use of knowledge graphs for fact-checking and such. So it's really a lot going on, actually. And I'm sure there is much more than this. There are probably things that I just forgot to include here, but it's a lot of effort happening, going on. So as the last point here, weakly supervised approaches is one of the approaches to fake news detection. And today I'm going to talk about a weakly supervised approach that we've been trying to develop. So as I said, this is based on a master thesis that has been done by Anya and Ingvild, and they've been looking into the fake news detection by weakly supervised learning, but by using only the content features of the article. So the master thesis is already out there. It is you can reach it from this URL. And I'm going to share these slides with Mehdi so he can make it publicly available. Yeah, so this here I'm going to first talk about this master thesis and what they did in this master thesis, and it's been supervised by me, this thesis. And then also the future work that we are trying to build on top of this this work. So our definition of fake news combines disinformation and misinformation. So this is our definition. We include publication of false information, either unintentional or with the intent to deceive or harm. And the main reason that we have chosen this definition is, of course, mostly the availability of the existing data sets, because the existing data sets that we can use for this task, they don't really distinguish between between unintentional and intentional false information. So therefore, we decided to combine them, and when I talk about fake news, I'm talking about the combination of these disinformation and misinformation. Also, we focus on the mainstream media in this work, mainstream media, like articles from mainstream media. And that is due to the importance of coverage of fake news in mainstream media, even though some people focus on social media and they think that the social media side is also very important, and I agree. But also we think that when the fake news or false information leaks into the mainstream media, it has a bigger impact on the society. And I know that some publication channels or some journalists were actually quite concerned about this. So we decided to look into the news articles from the mainstream media. Then why did we choose weakly supervised learning? So first of all, there are very few labeled data sets of sufficient size and quality for supervised learning in this domain. And that is, of course, due to the dynamic nature of news. The news is very dynamic. It's not an information that that is permanent, or so things keep happening and news keep flowing in. So it has a very dynamic nature. And of course, then it is very difficult to label these news articles because it keeps just flowing in. We don't have enough human resources for labeling of such news. Of course, there could be labeling of yeah, so that's why we are trying to automatize this process, I guess. Yeah, so we have scarce resources of fact-checking and labeling. We depend on humans to understand if that is really false information, fake news or not, and we need humans to label them accurately. And this is it happens very slow. If you look at an average fact-checking organization's webpage, for example, faktisk.no in Norway, just as an example, I think they have really, I don't know how many articles they can check in a month, for example. I don't think that is very much. So we thought that weakly supervised learning is actually a good approach to this problem. And weakly supervised learning has been developed to work with low quality labels, or also known as weak labels. And it's been developed in Stanford, so you can check this URL for more information about weak supervision. And we thought that this is actually a good way of approaching this problem, since we don't have really high quality labels in this domain. And then there is existing work that is using weak labels in the fake news detection domain. Obviously, we are not the first ones who thought that this would be an appropriate approach for fake news detection. So we started to look into, of course, the existing work, and we realized that most of them, or all of them actually, are using contextual features in combination with content features, of course. So contextual features, for example, likes, comments, shares, etc., from users. It can be also other different things, of course, but they are time dependent, so they change over time. For example, when a news article is published, the likes it would get, or the comments it would get, or the number of shares it would get may change drastically. If a news article gets very popular, suddenly it can start to get a lot of shares. Yeah, and also sometimes we see this, for example, some old news articles from, actually it could even be some years old, that suddenly gets popular and people start sharing them, and starts getting more comments, or maybe how people comment on it can change over time. So these contextual features are not static. It is also something that we need to think on a temporal scale. Also, it takes time to accumulate. If we want to use the contextual features such as likes, comments, and shares, we need to wait for some time before we can actually get a good amount of likes or comments on that news article. And it may sometimes be unavailable as well. So it is probably a good idea to incorporate contextual features, but given all these properties of it, it may also be difficult to really to effectively incorporate them in the system. On the other hand, content-based features, they are just features extracted from the title and the content of the articles. And we have actually tried a lot of things. We have extracted a lot of features, and these are just a few examples that I present here. And also, we know that from by looking at the previous research, we know that content features of fake news articles can be very different than the non-fake articles. So we thought that using content-based features can help us to or can give us good clues on the truthfulness, or the if the article is fake or not, basically. So therefore, we have a lot of features, and we decided to use only the content-based features for this work. We have come up with a general architecture of or we have a general architecture of the system. So this figure is taken from the master thesis. So we have a workflow here. So we have the data set, and then we have pre-processing and feature engineering steps, and then we have weak labeling system. Then after the weak labeling system, we have a document representation, and then we have 5 different N models that we experimented with. So I'm going to start with the data sets first of all. So we inspected a lot of data sets for this work, and there are actually it's good news that we have a lot of data sets in this domain. Of course, the labeling of these data sets, in my opinion, are still a bit can be a bit vague. For example, most of these data sets, they have a list of trusted sources for newspapers, and then they label the articles from those newspapers as non-fake articles, and then all the others coming from the list of untrusted sources, they are labeled as fake news. So I think this is a very, very high-level generalization. So we cannot say that everything that comes from an untrusted source is fake, whereas we cannot always say that everything that is included in a trusted source is true. Of course, maybe the ratio is still a good, has a good ratio of like fake versus non-fake, but I'm sure there are exceptions in this, and then the labeling is not 100% accurate. But anyways, so these are the data sets that we inspected. As you can see, some of these data sets are really large. One of the biggest, or maybe the biggest one, is the fake news corpus that has almost 9.5 million. And then there are NELA GT 2018, 19, and 2020. And you can see that some of these data sets, they include articles. Some of them has short statements. Some of them has the social engagement data. There's, of course, Twitter data with the tweets, user information, and social engagement. And then there are very specific ones, for example, Syrian war articles. And also there are data sets that include images as well as social engagement. So I think, yeah, if you are looking into the social engagement or the social media aspect of fake news, I think there are also really interesting data sets. However, we were working on articles, therefore we considered the data sets that include articles, and also we wanted the data set to have a certain size. Then we decided to go for NELA GT 2019, and not 2020, because when we were about to complete the first set of experiments, the NELA GT 2020 has been published, and it was a bit late for us for this master thesis, at least. So in the master thesis, and the results I'm going to present today, they belong to they've been experimented with the NELA GT 2019 dataset. And then we also manually gathered a data set, and that was mostly for testing purposes. So we have basically used a few fact-checking organizations, and then and also existing data sets. And then we gathered a data set that includes fake articles and real articles. And we know that these are really fake and really real articles because they've been manually fact-checked. So we thought that it's good to have a gathered data set for testing purposes, where we know that the labels are really trusted and it is not a generalization. So this manually gathered dataset is available on GitHub. The URL is here. It is not a big dataset. It has just 434 articles in it. But it is something, as I said, it is something that we know that the labels are trusted. So they have really high quality labels. And then the next step was pre-processing and feature engineering. So we in the pre-processing phase, it was just very standard way of preprocessing the articles: tokenization, punctuation removal, stop word removal, post tagging, and lemmatization. And then in the feature engineering step, we had features extracted from the content, such as stylistic features, part of speech features, sentiment features, and the examples I included here, they represent those three categories. The ones in the middle, the three ones in the middle, they are sentiment features, for example. And we have extracted really a lot of features. So these are just a very small part of it. And the whole list can be also found in the thesis. Yeah, so we have extracted the features, and also we ran some experiments trying to understand which of these features are actually the most useful. And then again, going back to this architecture, so we have dataset, we ran preprocessing and feature engineering steps, and then we have weak labeling. So in my opinion, the weak labeling step and the end models are really the crucial parts of this architecture. In the weak labeling step, we have tried two frameworks. They are weak labeling frameworks. That is Snorkel and Snuba. Here. So both of them actually are, they've been developed in Stanford University. So I think Snorkel is a little bit older than Snuba. However, it is a much more established framework. And Snuba has been published in 2019 in VLDB conference. And they also have a GitHub repository. That's where you can go and actually use the framework. So we've been running experiments to understand which of these weak labeling frameworks would be the most suited for our task. And as a result, we found out that Snuba performs better. Actually, it is not significantly better, but it has also a larger coverage. So we chose Snuba, and we just included, or we just used Snuba to generate our weak labels. And then we just continued with the data representation, where we have tried TF-IDF and BERT-based models, or where we have adjusted our settings for that. And then we trained 5 models for weakly supervised learning by using the outcome from the Snuba framework. So 5 models included logistic regression, XGBoost, Albert, ExcelNet, and Roberta. And so as you can see here, we have tried it with, so we wanted to compare it with supervised learning and weak supervised learning. We wanted to compare these two. So these are the results from our experiments. So you can see that Roberta outperforms the other models for weakly supervised learning, and also actually for the supervised learning. So this is really just a summary of our results here. And then we also wanted to test the effect of weak labels. So what happens? So here, so here we have 5 different models, and actually when we train these so first we have trained them with weak labels, and then we train them with regular labels we have. And then we wanted to find out what happens if we train them with all the weak labels we have, but then also we decrease the amount of weak labels. So I think this is very interesting. I mean, well, the interesting part is how the models perform for different amount of weak labels, because obviously the supervised method performs better at the end. And I think that is obvious because supervised method works with high quality labels. So that is something expected in my opinion. And then we introduced all the weak labels, and then we decreased the amount of weak labels. And I think that is very interesting because when we introduced all the weak labels, you can see that the accuracy is quite low. And when we decrease the amount of weak labels, it goes up. The accuracy goes up. So it means that the more weak labels we have, there's a decrease in the accuracy here, and also F1 score. So we find this very interesting. Maybe weak labeling actually is introducing some noise into the classifier. So we have some conclusions as a result of these experiments, initial experiments. So SNUBA outperforms Snorkel for this task, as I already mentioned. And the more weak labels we introduced, the more the classification performance decreased. However, the decrease is not that significant actually. So it is still okay. I think if you look at the F1 score, for example, there is not a very significant decrease. So in general, we think that weakly supervised learning can be considered suitable in the absence of high quality labels. So if we really don't have anything, I think weakly supervised learning is still a good enough method to use in this context. And of course, in case we have good quality labels, then supervised learning is the way to go. But also given the dynamic nature of news and the difficulty of generating high quality labels quickly, I think weakly supervised learning is definitely a promising approach. And as I said, this is our initial work. So as the future work, we want to investigate the ways to use weak labels without compromising accuracy. Is there actually a way? So we need a little bit more research in there actually to understand what is causing the loss of accuracy or the loss of performance. So is it really adding some noise into the data, or is there another reason? And of course, we definitely would like to try additional data sets for verification of these results. Because of the time constraints of the master students, they were only looking into just one data set, that is NELA GT 2019. And it would be very interesting to try it with other data sets to see if actually this is valid for all the data sets or specific for this one. And also, of course, it would be interesting maybe to modify the architecture. There are some details of the experiments that we would like to try a few different things. So there are many challenges still. There are so many things to look into in this domain. There are so many approaches that can be improved and that can be tried. So it is really it's really, in my mind, it's really like this puzzle pieces. So we have a lot of different approaches, a lot of different channels of fake news, its distribution, its spread, how it is generated, the language of it. There are so many aspects of it, and there are so many pieces that needs to be improved. Like every piece needs to be improved, but also how we actually combine these pieces in the future is a very interesting and challenging task, in my opinion. So thank you. This is my presentation.